Yesterday we read the text for T2L3 air masses. Today is all about marking the text. So please follow along and mark your text in your book as we go through the text. For the first page, what I'm going to be marking is my guiding questions. So you can see everything I've highlighted this time, I'm going to highlight in blue. How do global patterns such as jet stream affect air masses? How do air masses interact to form fronts? And then finally, how do the interactions of air masses result in changes in weather? Take a moment, highlight that, pause if you need to, and move on when you're ready. If you have not done the marking of the paragraphs on our next page, please mark 1, 2, 3, and 4. In my first paragraph, what I looked for is vocabulary, the definitions of the vocabulary, and what are the big ideas in each paragraph if there was something that stood out. So my first major idea that I'm looking at is major air masses. So I highlighted after air mass in paragraph 1 is a huge body of air that has similar temperature, humidity, and air pressure at any given height. And then I highlighted scientists classify air masses based on temperature and humidity. So in this paragraph, this is what I found to be important. That's really touching on what the big idea is. In paragraph 2, I looked at it and I discovered that everything is talking about characteristics. And the characteristics, so I highlighted, is air mass depend on temperature and moisture content of the region over which the air mass forms. And I actually should really highlight, let me get my blue again. I should also be highlighting characteristics of an air mass. So if you don't have that, go ahead and put that in. Moving along a little bit further, my next section, paragraph 3, talks about how air masses move. So I'm looking for things that tell me how they move. And the first thing I highlighted was air masses are commonly moved by the prevailing westerlies and jet streams. So that specifically answers how they move. They've got an entire tiny little paragraph devoted to that, so it's probably pretty important. In paragraph 4, I'm still looking at how they move. And again, we're talking about prevailing westerlies and what they do. They push air masses from west to east. So it's really telling me the direction that they are pushing the air masses. So that's important. They're talking about how the air masses move again. Further down, it's again talking about how air masses move because it talks about the jet stream. So I highlighted that. It's a band of high-speed winds about 6 to 14 kilometers above Earth's surface. And then my final sentence says, the movement of these air masses and their interactions have a great impact on weather. So that's all tying back into the weather, and it's talking about how they move. Pause if you need to. Make sure you've got everything highlighted that I talked about before moving on to the next section. When you move to page 68, please make sure that you have numbered your paragraphs 5 and 6. You can see that over here on the left, I did put in some hints about what you're going to have. Same thing I wrote on the board, or hopefully have written on the board, about what you want to label that area. You're going to be able to see how you did on that and make changes if you need to. So in paragraph 5, I did something a little different. First, I did highlight in blue. So paragraph 5 is talking about types of air masses. So I'm looking for big ideas that talk about types of air masses. And I highlighted that weather in North America, which is where we live, is influenced by one of 4 major types of air masses. So I thought this was really important. So I did highlight the 4 major air masses. There's maritime tropical, continental tropical, maritime polar, and continental polar. But not only that, because I wanted them to stand out a little bit more, so I put a box around each of them. So take a little bit of time, highlight them, but then maybe set them apart so they stand out for you. That might mean highlighting or using a pen and circling them or putting a box around them, but do something so those 4 types of air masses stand out to you. And then in paragraph 6, we're going to look at what do each of them mean. So in paragraph 6, it's a big chunk that I highlighted here because it's got a lot of really important information about the types of air masses. Tropical or warm air masses form in the tropics and have low air pressure. I definitely need to know that. Polar or cold air masses form in the high latitudes and have high air pressure. Maritime air masses form over the ocean and are very humid. Continental air masses have less exposure to large amounts of moisture and are drier than maritime air masses. If I look at the word maritime, mariner, it derives from the same word. That means water. So anytime we're talking about maritime, we're talking about water, over water. When we talk about continental, continent means land. We're talking about areas over land. I did highlight one other thing. At the very end, I highlighted large bodies of water moderate air temperatures. So think of it like moderating, being controlling, or having an impact on them also. Now, the reading check, what types of air masses affect the weather in North America? Hopefully you got this one figured out, but the correct answers are maritime tropical, continental tropical, maritime polar, and continental polar. And then as we look down at figure 2 here, go ahead and make changes if you need to. If you need to pause it and make some changes, that's totally fine. But the correct answers are, when we talk about maritime polar, okay? So maritime means moist, okay? So we're gonna have some moisture there. But because it's polar, it's cold. When we say continental, that means we're over land, so it's going to be dry. And anytime we have polar, it is cold. Down here in the bottom right, we've got maritime tropical. So it's maritime, so it's over water. That means it's going to be moist. And tropical, I always think of Florida, it's going to be warm. Continental, again, we're over land. And when we're over land, we're dry. It doesn't have as much water to draw from. Like we've got the Great Lakes and things. But when you've got maritime, you've got the ocean to draw moisture from. When you're over land, you have very little area to draw moisture from. That's why it's dry. And then since it's tropical, it's warm. Make sure you get those filled in correctly. Make changes if you need to. Pause if you need to before moving on. On page 69, please make sure you number your paragraphs 7 and 8 for types of fronts. All right, now that we're ready to do some highlighting here, I did highlight the types of fronts. That's going to stand out to me. And when I start talking about types of fronts, it wasn't until really at the end of the paragraph that I really found something that I thought was really important to highlight. So for me, it says the boundary where air masses meet becomes a front. So it's actually telling me what a front is. It's that boundary line. And then storms and changeable weather often develop along fronts, like the one in figure 3. And now down in paragraph 8, it's actually telling me the different types of fronts. Again, there's 4. We have 4 types of fronts. We have cold fronts, warm fronts, stationary fronts, and occluded fronts. And then my last sentence, if you've noticed a trend here, a lot of our last sentences are really important. The kind of front that develops depends on the characteristics of the air masses and the direction in which they move. Now, I forgot to do this. I'm going to do this right now. I'm going to turn on my green pen, and I want to make those 4 types of fronts stand out again. So I've got cold fronts. I've got warm fronts. I've got stationary fronts. And I've got occluded fronts. And I think those are really important, and I want them to stand out. So when I go back through, maybe study, look for an answer, I know those are going to pop right out at me, even out of the highlighted material. Take a moment, finish your highlighting, pause if you need to, continue when you're ready. All right, we are on to page 70. We're going to number our paragraphs 9, 10, 11, 12. And here's what I highlighted. I did highlight, as you can see, each of the names of the different fronts, because we're going to get a little bit of information about each one. So if you want to start with that, go right ahead. In paragraph 9, we've got cold fronts. And what really is important about cold fronts is some of those characteristics. It brings heavy rains and winds, thunderstorms, and even tornadoes. So I want to know that cold fronts bring those types of weather. In paragraph 10, for warm fronts, I want to know along the front, light rain or snow can fall if the warm air is humid. So I want to know about that type of weather that goes with it. In an occluded front, a warm air mass gets caught between two cold air masses, forming an occluded front, and rain or snow may fall. So this one I'm telling a little bit more about it. And then stationary fronts, it's a non-moving front that's called stationary front. And the type of weather is days of clouds and precipitation. Okay. Also on this page, we did have our reading check. It said, what do all of these different types of fronts have in common? You're welcome to change your answer if you need to. The correct answer is they are all created by the interaction of warm and cool air masses. So when we talk about interaction, it's about those warm and cool air masses, running into each other or doing something, getting stuck together. That's what we're looking for when we talk about that. Go ahead and pause. Actually, we're not going to pause. If you need to pause to highlight, go ahead, but I'm going to continue on because we've got the pictures. The pictures I did highlight, you can see, and I highlighted the other ones above on page 70 also. The pictures are going to be important, so I would highlight those. In fact, if you want to put a circle around the pictures so you remember them, go ahead and do that too. We did have the evaluate information. How are cold and warm fronts different? The fronts differ based on how the warm and cold air masses are interacting. So this is something, if you need that, go ahead and pause, change it or add it in, whatever you need to do. And that'll be really important for you to know also how they are different. Go ahead and pause if you need to. Now that we're ready, we're going to go ahead and look at page 72. Please make sure you number your paragraphs 13, 14, 15. This is the end of what we're going to be highlighting and taking a look at. On 13, I highlighted our heading. Everything on this page is about cyclones and anticyclones, and I thought that was pretty important. So in paragraph 13, I actually didn't highlight anything. You're welcome to if you feel there's something that is really important. It does have a really good sentence here. When air begins to swirl, causing the low pressure center to form, areas of relative low humidity pressure. You are welcome to highlight it if you want. I chose not to. I did start with cyclones. I highlighted that and the definition of it. It's a swirling center of low air pressure that can form a cyclone. And then what I talked about or highlighted later on that was really important to know about a cyclone is a cyclone always spins counterclockwise in North America. As air rises in a cyclone, the air cools, forming clouds and precipitation. So counterclockwise means if it starts here, it goes this way. In paragraph 15, I highlighted anticyclones. And an anticyclone, I said, is a area of high pressure center of dry air. So that's really important to highlight. Also highlighting wind spiral outward from the center, moving toward areas of low pressure. That outward is important. Okay. And then also I need to know that it spins clockwise in the northern hemisphere. As the cool air warms up, its relative humidity drops. So no clouds form and the weather is clear and dry. So in this case, spinning clockwise would be like this, like a clock goes. And then our final question for reading check is, how do cyclones and anticyclones differ? So not how are they the same, but how are they different? And the best answer is cyclones are areas of low pressure with winds spiraling in the center. Anticyclones are areas of high pressure with winds spiraling out from the center. You can also mention clockwise and counterclockwise. Those are areas that they differ. Okay, so please make sure you've got any changes made that you need to make. Highlight what you need to highlight. If you want to add something else in for highlighting, you're welcome to do so. Please make sure you are ready with your text marked because it will help you as we get to the end of our lesson and then do our quiz for it.